Hello, everyone. My name is Anthony Beadham, and this is my final project for computer graphics fall 2021 with Professor Mike Shaw. So I implemented a procedural terrain generator that uses the Perlin noise algorithm to generate a height map that can be utilized with the code we'd already worked on in the lab on generating terrain. So I utilized a few different tutorials, as you can see here, because each one of them covered a different component that I wanted to see in my final project. If we run my project real quick, we could see that we have a terrain that's been generated with our noise generator. You see the different components. At our low points, we have these bluish colors representing the ocean, and that transitions up into yellow and green and red at the highest points of the mountains with these snow caps at the top of them. Let's go look at our code real quick. So since this is a noise generator, we have to have this element of randomness or pseudo randomness. So what this function is doing is we just give it a seed and it will end up producing this hash table that we can use to extract this randomness. Here we see an example of a table down here. And having something we could just give a seed and get this random array of values out of allows us to do something like this in our program, where I can just hit the S key and I can tell it to generate a new map utilizing a different seed. And now we have different terrain. So going back to our code, we'll take a look at our noise function, which just takes in a coordinate pair like an X and a Z, for example, and it produces a floating point value, which can then be mapped to something like a Y coordinate value, which is what we do in our project. So on the right side, we could actually see some examples of noise maps or height maps. And if we look at any point on a noise map, if you look at a dark point, for example, you know all the points around it are more likely to be dark than white. Or if you look at a white spot, it's more likely to have neighboring white spots. And that's because the Perlin noise algorithm allows us to have these very smooth transition between our high points and our low points. And that's how we end up getting the terrains that look smooth like this right here. So we can do different operations on our noise function, like we can multiply the input coordinates by a frequency to get different clusterings, which is how we get results like we see on the right side that are very different from each other. Or we can multiply the final return value, the Y coordinate, by an amplitude to get different height values. So armed with that knowledge, we could actually take advantage of that, and we can produce different noise maps by using these different frequencies and amplitudes. And we can stack them on top of each other to get this new looking noise like this right here. So if we go back into our program, we can see what happens if we mess around with those parameters like frequencies, amplitudes, or something called octaves, which octaves tells us how many times we're going to iterate through and how many noise maps we're going to make and stack on top of each other. Right now we have 8 octaves, but if we go all the way down to 1 octave, we'd see how simple the map gets. And with each octave we add, it gets more and more complex. If we increase the amplitude, we'd see all the points get higher at the highest levels and the low points get lower. And we can increase it. We can adjust the frequency to get closer clusterings like this. Or we can decrease the frequency. Let's go back to normal. We can adjust these other values like linearity or persistence, which tells you how much you're going to change the frequency or the amplitude between each iteration you do for each next noise map or each next octave. So if we increase linearity, for example, we can get these very sharp, very rough looking maps with a lot of detail, or we can decrease it and we can lose a lot of detail. We can adjust the persistence, which affects how fast the amplitude changes with each iteration. They can get very complex very quick. And if we go back to our code one more time, the final part of the project is actually just coloring in this terrain. Since we are generating the terrain procedurally, we can't hand draw it, so we have to come up with a procedure to color it. And this is code that we have in the fragment shader that just tells us to color the fragments based on what their Y values are. So you can see we have one color for the snowy mountaintops, and it's going to be white. Right below that, we have the the midland to mountain transition, that's the green to red transition. Below that, we have the coast to midland, which is the yellow to green transition. And at the lowest levels, we have the ocean, which is going to be colored blue. So thank you for looking at my project. Have a good day.